Hello, welcome everybody. My name is FOSDEM. I work for the OpenNebula systems, and right now we will speak a little about the edge clouds and how we understand the edge clouds in context with the OpenNebula. I have to say that I won't do any like a real demo, but I'm starting just to show something, and I will describe it a little later. So just for the reference. So about the edge cloud, it's necessary to say that our work, our current work, and our future works receive the funding from the EU Union from the Horizon 2020 research program. This talk is divided into mainly three parts. In general, what is OpenNebula, if you don't know, then how we understand the edge clouds, and then what we do or what approach we or what tools we provide to build the edge clouds in the OpenNebula. So just a quick poll. Who knows what is OpenNebula? Just a quick. Good. And who uses OpenNebula? Great. So just to summarize, OpenNebula is a framework to build infrastructure as a service cloud. Mainly we focus on the private cloud. We talk about virtual machines powered by KVM or vCenter and the system containers powered by LXD. We support various cloud deployment architectures, but mainly what we focus on is on-premises private cloud. Usually it's OpenNebula is appreciated for being light and simple, extensible, easily upgradable when compared to other systems. It supports various popular Linux distributions, CentOS, RHEL, Ubuntu, Debian, and so on, and it's fully open source under Apache license. And it's with us for some time already. This is how it looks like from the perspective of the graphical control interface. A list of virtual machines, at the top a list of buttons. You can control reboot and power off, distro, and these kind of stuff. If you want to see all the features, there's a discover page which lists them. If you want to try the OpenNebula, there's a really cool tool written in a shell called Mini1, which simply configures all the OpenNebula, like a front-end part and the hypervisor part, on a single selected node. Simply creates some kind of evaluation or testing or maybe development environment. So it's really great, and it takes just 5 minutes or something. If even interested more, let me invite you to the OpenNebula conference, which is like every year. This year it's in Brussels, just a few months later. Now let's focus on the edge cloud. What is edge cloud for us? For us, it's the edge clouds are the micro data centers, which are with some kind of cloud-like capabilities and are deployed very near to the end users or end devices they need to interact with. So the benefits are to provide lower latencies, provide like new features which this lower latencies allows. Probably some preprocessing can happen in the edge cloud, so the data which are sent to the central cloud are much lower, or there can be a need due to some security or privacy reasons. But everything is not just a green or good. There are some limitations. Limitations comes with a limited offer of the hardware or software we can use in the edge, and there are also some risks, potential data loss or maintenance overhead, and so on. But from the perspective of the OpenNebula, edge clouds are very similar, or should be very similar to the on-premises cloud, which is on the left side. So the main difference is we can expect there will be much more such smaller clouds, and they will have kind of dynamic nature. They can be created dynamically, destroyed at any time we need. So they are kind of ephemeral. they are also restricted and kind of limited. From the implementation perspective, we talk about the infrastructure edge. So that's the part of the edge which is powerful enough to run like a more demanding computation and so on. Our aim is to take the technology we are using for the on-premises cloud, or the KVMs, LXD, VXLANs, and all these building parts, and just move it to the edge cloud. Of course, with help of some specialized drivers and in a form which is like designed to run in the edge cloud. We very much rely on the existence of a bare metal cloud. So OpenNebula never installed the physical hosts, operating system, and these kind of things, and it won't do. So we expect there is some service provider which manages the infrastructure and is able to give us or give users the resources which can be used to build the edge cloud. The second important part is automation. Everything is automated. On bare metal cloud, we don't care that much. It's the provider's duty, but on the host level, everything is automated. Hypervisor is installed, operating system is configured to run as part of like a virtualization cluster. And it's good to say that the only thing we do is just take all the great open source tools we have, distributions, hypervisors, and so on, and put it together to build open source edge cloud. So to summarize, the OpenNebula edge clouds are just limited OpenNebula virtualization clusters you might be running already on premises. They are deployed on infrastructure of some third party. They are managed fully automatically, and I've introduced this kind of buzzword, infrastructure service in infrastructure service. Because when you are running virtualization cluster on premises, everything is kind of okay for you. You have hosts under full control, you have storage, you have network, and choose your addresses. So you don't have any problems. But if you have to deploy the similar virtualization cluster on some third-party infrastructure, probably hosts are also okay, storage as well. But when it comes to networking, we can expect there will be some limitations introduced by the provider. And regarding the IP addresses, there definitely will be some restrictions. So these two things, network things, are kind of challenging parts we have experienced. From the network perspective, it's very environment specific because various providers introduces some various features, like a dedicated VLANs for you, but also some limitations, like a no multicast support. So the solution or the approach we have to take is introduce some kind of common virtual network model, which is able to work no matter on independently on the provider. So we are using the overlay network, VXLANs, but we don't rely on the multicasts. So it's just for the unicast environment. The more complicated thing is the IP addressing. In case of private addressing, maybe we don't care because we have our overlay network and we can do anything and nobody cares except us. In case of public IP addresses, the situation is much more complicated because we just can't take our favorite IPv4 address and put it into a virtual machine and expect that everything will work. Usually the IP addresses are kind of agreed with the provider. You ask the provider for some pool and they give you some addresses back. So this, like a workflow, needs to be automated. And in case of edge clouds, it's automated through some kind of IP management drivers, which exactly comes to the provider and tells, give me some IP addresses. So that's just one part of the problem. The another part of the problem is that you have some IP addresses, but usually you need to notify the provider when you want to use the IP address on the selected host, so that he updates the routing or something to get the traffic to the right place. So about the IP addresses, two problems there. The conclusion from this part is simple. If you take some existing infrastructure as a service framework and try to run it within different or maybe the same infrastructure as a service, you can expect the things to work without problems. Now about the provisioning. About the provisioning and how do we build these clouds. OpenNebula comes with a set of specialized tool, drivers, and configurations, which simply talks to the providers and builds all the cloud, just like with a single command run. Mainly we target on the edge clouds, but possibly it doesn't have to be only edge clouds. So once again, it's a one provision tool which manages the whole life cycle of this edge cloud. It's command line only. Then we have some kind of integration drivers. It's good to say that when some like a third party or provider selected, there needs to be two kind of drivers. One driver which is able to allocate some hosts from the provider or release the host back, and the other thing that is mentioned, IP management integration driver, let's say. And of course, we have hosts with base operating system. We have some addresses, IP addresses. Then the missing part is to configure the hosts so that they can be part of OpenNebula cluster. So the last part is like a configuration playbooks and rules for the reference architectures. That's what user or cloud administrator usually gets, but he has to do something. He has to write some provision descriptor which exactly specifies what provider to choose, what are the credentials for the provider, what hardware configuration to use for the machines, what to create inside the OpenNebula, what data stores, virtual networks, and so on, and also how to configure the hosts inside. This is created by the infrastructure administrator, and the process is, the high-level process is as simple as displayed here. So basically, prepare the descriptor, pass it to the tool, wait 10-15 minutes, and you will get an independent virtualization cluster at the edge. Management features of this tool are like a very simple, very limited. It can create an edge cluster and destroy the edge cluster, and the other options are more host focused, power off, reboot, resume, and so on. So to summarize the current state, we have an integration, I would say a good integration with the packet provider, and we have some partial integration with the EC2. We have a tool, I will show it a little later, hopefully, which can deploy the cloud. It's more like an advanced tool. There are some missing features, like a cluster can be scale out or scale in, and the architecture which is deployed there is very simple, like a single static one. The future plans, as I mentioned in the beginning, we have received some funding from European Union. The idea is to take what we have and to build from that some like easy to use edge cloud solution, which incorporates some catalog for the edge providers and marketplace for the edge application and so on. Mainly that means that we will get new integration drivers for new providers. We will get new features like a cluster scaling or cluster update. The work in progress is a support for lightweight virtual machine monitors, like a firecracker, and caching data stores, and possibly cross locations networking. Good. About the documentation, if you go to the OpenNebula or docs.opennebula.org, there is a section which is called Disaggregated Data Centers, which describes all these things and tooling and how to write the provision descriptor or what configurations you can use and how to parameterize it. Also, I've mentioned the Mini1 tool at the beginning, which usually deploys just KVM or LXD single host and evaluation environment, but it can also deploy the edge. As seen on the screenshot, it just needs some parameters like select the provider and give some token and project, and it does everything automatically. This is not something like an artificial thing, but we did some use case validation demos. The most important or the most interesting thing is the video gaming, when we have used this tool to deploy around the world 17 edge locations, which were like small KVM clusters, and run on each location one virtual machine, which was running inside the Wolfenstein enemy territory game server. And then from the office, we connected to random one in Sydney, and we could play, and it worked simply. It was as easy as running just a tool and waiting, unfortunately, 25 minutes, because some locations like Japan took more time than some other locations which were much nearer. We have this nice data sheet. We describe all these demos. We can give you if you are interested. Also, we have stickers. If you are OpenNebula user or just interested, come to us, and we will give you all like details you would be interested in. So maybe we have some time for demo. Firstly, I will probably show how the provision descriptor to build the cloud looks like. It doesn't have to be necessary to understand all the parts, but just the concept of what is necessary to specify, right? So on this page, the most important part is the playbook, exactly the configuration applied on the host. Then there are some defaults which are specifying like a driver and credentials. We are also choosing the bare metal hardware type and CentOS and so on. But in the next part, we just list what host and the number we want to deploy. Then we specify data stores which should appear in the OpenNebula, and the last part are the networks. Exactly, this is the thing which creates the public IP network with the IPAM packet driver, and it requests two IP addresses, two IPv4 addresses from the provider. And there are some private networks. So basically, this is enough. And I've started this provision command before I started the presentation, and you can see it took 20 minutes. 12 minutes to deploy 2 hosts, to deploy 3 virtual networks, and some data stores. Maybe I can try to start some virtual machine. I have to do some like a workaround. To make this working, because I have Alpine image here locally on my laptop, and I just share it to the edge cluster I have right now deployed. And I go to the OpenNebula. I'll make it a little smaller. Yeah, I'm finishing. And the thing is that I will run this Alpine Linux on the edge cluster I have right now deployed. It would run as is. The interesting part is the networking. So I will specify a host-only network, not to break it, and I will give it an alias for the public networking. So maybe I can try 2 virtual machines. Good. And if we wait for like 20, 30 seconds, it's already deploying. We can check what is the host exactly. Okay. We can't check, but trust me, it's a packet hosted machine in Amsterdam. Yeah, maybe I can show the packet dashboard. It was updated, so you can see this is the FOSDEM node 7577, which is exactly what is seen here. Yeah, unfortunate thing is that it's copying the image. But if that happens, we should be able to ping the virtual machine there. So, and that's the goal. That's the goal. On third parties infrastructure, be able to build a KVM LXD virtualization cluster we are used to, and have the most of the features we are used to from the on-premises, and also be kind of integrated with the provider, have a public network working, and so on. So, yeah, let's check the first one. Just it's booting, and I can just try to log in. Wow, I could log in there. I can check the ifconfig, and I can see the private address, which is assigned inside, is the very same. It's 0.3 address. And trust me that it's the Alpine Linux I just deployed. I can see uptime 0 minutes. So that's it. The very last thing I will show is that the way I've created this virtualization cluster in just 12 minutes, I can destroy this cluster the very same way. I just need to remove the hack I did previously. I'm trying to list the provisions, delete it, and it won't work right now because we have running virtual machines there. But I can ask it to clean up, and it simply terminates the virtual machines, both. And when it's done, it cancels the hosts and releases the IP addresses back to the provider. Let's check. There are no hosts. And we can check the packet that everything was released. They are not updating it, and here's nothing. So, as said, we have this data sheet here describing the use cases and plans. You can talk to us if you are interested. Also, we have stickers. Please come to us. Thank you.